All right, so I wanted to make this video because I know that a lot of people are having some issues, especially for the people who have the latest Mac OS. So today I tried to see if there are other kind of documentations or tutorials that we can follow and try to find a solution. But unfortunately, it was kind of very painful because I didn't find any documentation. So basically, I did, I exchanged everything that we did, that we were supposed to do with Omni to the graphic user interface element or tool that GENI has. So basically, I know that you are a little bit familiar already with the platform, and I know also that you have already tried, you joined one of the projects that we asked you to join. So that's kind of the first step that you have to follow. I'm gonna open the file that I updated, and I'm gonna walk you through it. I didn't make any changes at all in the terms of the content of the lab. Basically, the main difference that we wanted to give you is like two options on how to create an experiment in GENI. But in this case, the lab is going to be entirely in the GUI or the graphic user interface or JAX instead of the command line Omni tools that unfortunately didn't work for us. So we still have the same purpose in this lab, the same references. The links are the same, are exactly the same that we had before. The steps as well. We learn about GENI, as I told you last time. A lot of the GENI terminology in the beginning is a little bit confusing, especially if you want to, compare this with AWS or any other web server. It's a little bit confusing, but there are some key terminology that you need to understand to accomplish this lab. So I welcome you to go through like these links and try to understand. We give you a couple of terminologies for you to read as well, and you have to send that as your report. But I feel like if you're curious or if you want to learn more about GENI, you can go through the documentation. We have the same, as I said, steps and some guidelines that in the beginning we learn about GENI, then we learn about the architecture, how to create an account, how to set up an environment, and then we do the hello world. As I told you last time, every time you try to learn like a new technology, a new programming language, or anything related to, learning something new, they teach you how to do a hello world. So I feel like this is going to be very important for you to understand and to learn, and it's going to be very useful for you as well. So we continue. The first step is pretty much learning about the terminology and architecture. Again, we put here 2 links that we initially have, so we keep those. And then here we have this experiment workflow, and pretty much comprised the experiment workflow with GENI, the architecture. So from the beginning, you design the experiment, you know what you want, and then you execute that, and then you finished. It's like straightforward, but again, there are a lot of steps that they're working behind. So it's just to have an idea of everything that is connected to each other, in the sense of it doesn't matter if you're creating like a very short experiment, still there is a lot of things going on behind. So the first thing, I think at this point you all have your GENI account. So you pretty much went over the portal. you looked for, if this is the first time you're using GENI, you have to look for your institution or your organization. In this case, you look for University of Missouri, and you access to this portal when you go to this link. Yeah, basically you just continue, and you have probably learned why we have to do it in this way. So that's why it's like in the beginning, what we did was we had to associate this account with a class or a project in your case. So what we did was in the beginning, before we started the experiment or the lab, we created this way to join a project. And basically we sent out like a solicitation to Dr. Kalian to give you access to the project. So I feel like at this point, everybody has a done till here. I don't think anyone will have any issues to get in like the lab until here. So then the things move a little bit more here, especially for the people who has Windows computers. So in this case, you can have another workstation. We're giving you here VMware workstation, and especially because it was free and it was easy to install. But I put a note here that if you're more familiar with another hypervisor, of course, you can set up your virtual machine in anything like VirtualBox or any other a workstation that you feel or you are more comfortable with. But we really wanted to give you like an example to follow, because it's going to be like harder for you if you never use workstation before, just to ask you, okay, install a workstation and then install like a virtual machine with a Linux based OS. So we wanted to be more specific, and we are giving you here like an option. But as I said, if you're more comfortable with another workstation, VirtualBox, or you have any other version, there is the paid one, feel free to use that. But as I said, we're giving you an option. And again, the Linux image that we are providing you here is the 1804 one. And the reason why we are giving you this version is because you might have one that is newer. That's fine. But as we tested the lab, this is the version that worked for us. So you can try it if you have already a virtual machine set up and you have like another Linux image that is like newer. You can also try with it. We're giving you here an example, like with a version that is probably older, what you can find now, but we know that things work with this version. Again, we are sharing some screenshots here that you can follow. Pretty much using how to use the workstation and how to install the image that we also provided you the link to download. And then you make some configurations like the disk size, and then other things here as well. After that, you should have something similar like this, and you should be ready to run your experiments in the VM that you choose installed. And here things move on. This is for everybody. Everybody has to start working on this. Computers, Mac OS, they should work. I made everything in a way that you can run the experiment using the JAX or graphic user interface. We are not gonna use the Omni command line tool. So it should be very straightforward to go through the Hello World experiment. I think the important part of this is to learn and to understand that you as a GENI user, you have like different options on how you can allocate resources or how you can create your experiments. So for us, what we are doing is we are interacting with the GENI portal, and then we have two options to do this allocation and how to create our experiment. So we can have the JAX, which is the option that you have with the graphic interface. And then you have the Omni one that is for the command line the one that previously we tried and it didn't work for us. And then of course you work, there are things behind that. For example, the R spec that we share with you is like the recipe where you have everything in terms of the components that you need for your experiment, the characteristics, and everything that you need to allocate, the kind of machines that you need, the kind of computing nodes that you need. They're all in the recipe that we call RSpec. We also give you this file that you can download from Canvas. Basically, a lot of, what is a slice, what is like the silver, the RSpec, how to instantiate, to access and verify this sliver. You can access to all this terminology in the wiki, in the GENI wiki as well. Then to run the Hello World experiment, you have 4 specific tasks. For the first one, what you have to do is you have to generate your key pair. If you've never done before anything related to SSH or to SSH a node, this is a great opportunity for you to give to give it a try. This is going to be also useful for you if you start working with AWS. It's pretty much the same thing. You have a way to generate some SSH key pairs. Basically, you have always the private one and the public one. The public one is always with a dot pub extension. So that's a very easy way to differentiate between the public and the private key. But in this case, we are going to generate a private key and we are going to download that to our computer because that's what we need. That's kind of the key that we have and that is personal, that we can have to help us access to the computing nodes that we are allocating. So we just follow the instructions here. We generate, this is for someone who have never created key pair in GENI. So I had a lot of key pairs before, so I had to remove everything that I have in order to show you like everything in a fresh state. So pretty much you generate your SSH key. As well, it's gonna ask you for a passphrase. Basically, it's like a password that you need to access the key. So again, you need to create this and you have to remember, because if you forget it, you have to create another key, and it's kind of easy if you put a passphrase and you make a note of it, and then when you have to SSH to the node, you have it with you. So I'm moving here to the generation of the SSH private key and the passphrase that you have to put. So by default, the SSH key pair is gonna be called like this. This is gonna be the name of your SSH key pair. In particular, this is gonna be the private one because the public one is gonna end up with PUB. So the one that we need is this one. So this screenshot is something that you can access through GENI. So if you go to your profile, SSH keys, this is the way you access to this file. So after you generate your private key, you're gonna have these options. So what you're gonna do is you're gonna download the private key, and then after you download the private key, you have to run these command lines in your terminal. So try to read very well the instructions that are given to you here. Don't just run command lines without really knowing what is the purpose of it, because sometimes we can mess up things. So it's kind of very important to understand what is this command line doing, for example. And if I don't know, I can go and I can learn about it, what it's doing, what is this command line doing. It's kind of giving you here like the explanation of everything that you're running. So try to read through every line so you know really what you're doing, and that's going to help you to go straight forward and you're not going to mess up anything. So let's go back to the lab, and you download, you follow the instructions that are given here. And then after you're ready, you have your key pair, you have everything configured, what you have to do is you have to create your slice. So you pretty much go to the project and you select create slice. In this case, we don't have anything here, but I can also show you from my, I have various here because I've been working in other things as well. So if you go to slice, and then you click to new slice. So for us in the documentation, we don't have anything here. In my case, I have like different ones because I've been trying different things, but basically you create a new slice here. So this is the same like you have here. And then you have to then choose the name of the project, name the slice, and then you have like a description that you can put to the slice. And then you pretty much create the slice. After you create it, you have two other resources. And this is where the RSpec file comes, because as I said before, we are giving you the recipe of what we are looking for, basically. So you add the resources, and then you have to go to choose file. And the file that we are going to import is the lab1 RSpec, the one that we gave you in the Canvas page. So pretty much you choose the file, and then immediately you're gonna see the topology, the same one that we have here. Pretty much you have two nodes, and they're connected. One is client and the other one is server. So the first thing that you have to do is you have to assign certain IP addresses to each of them. So for doing that, you have to click in the, I might call it like a square node, which is a local area network node. You click in there, and then you can put some configuration here. Like the only thing that we have to change in this particular case is the IP address and the net mask. These are the two things that we have to change. And both of them you're gonna find in this part. If you scroll down a little bit more, you're gonna find the server and the client. They're one below the other. So you do this IP, you assign the IP addresses, and then you should be ready. Another thing as well is like, if you are curious about what is behind the RSpec file, it's gonna be very easy for you just to click in view RSpec. So pretty much you can see, as I mentioned before, like the different, the way the RSpec files work is they communicate with the request that you make to the aggregate managers. So pretty much you put all the ingredients that you need for your experiment. So you can be a little bit curious and see like a lot of the terminology that you learn in the beginning, that you read from the wiki, is going to show up here, so you can take a look and see what is behind. So that's going to be important as well. You move a little bit more in here after we have the two nodes. Like both of them have the IP addresses assigned. What we are doing is we decide where we're going to be allocating these two nodes. So in my case, in this particular example, I decided to allocate my resources in Colorado instead GENI. So I just click, I have many options. Usually the ones that are available, it gives you this green check. So you can choose anyone. I don't want like everybody to choose Colorado because you might have issues if everybody's using it. So you can decide anyone here that you feel like you like it. So you just choose it. And then what you do is you click to this small button that it says reserve resources. You don't have to do anything else, like any configuration. The only thing that you change is the IP addresses that you assign to each node, and then that you have to decide where you're gonna allocate the resources. And this might take you like sometimes 10, 15, 20 minutes max. And what happened, there's gonna be a lot of, progress going on behind. You can be curious again in this section. You can click in detailed progress, what is going on with the RSpec file. You can check the results. It's going to take you like around 15 minutes. And then after you see this message here that it says status finished, that means like your resources are already allocated. So you can go back to the slides, that you just created, and you should be able to see both client and server like in a green color. So that means they're available. You can have access to them. And then as well, you have here like the message that says that your resources on Colorado InstaGenie are ready. So what we are going to do now is we're going to try to SSH to the nodes. So basically, we are going to have access. These are like Linux-based computers or computing nodes. So what we are doing here is we are going to SSH to the nodes. I'm putting here an example. Let's say I made an allocation in Illinois inside GENI. So what I have to do is I have to click in client and then SSH, and it's gonna open up this tab, I might say, in your browser, the same one that you're using, the same one that is open, and it's gonna give you like an information. The key elements that you need here is the node address and the port number. So basically you make a note of these two elements here. You can copy paste. After you have this node address and the port number, you should be ready to go and you should be ready to SSH to the nodes. Again, I put a note here that is going to be very important to you to understand what is like the function of the private key, why you have to move this private key to the SSH folder. So you need to understand very well what is behind, because sometimes you might have certain issues especially with the permissions. I've seen that a lot. But basically you can have issues with the permissions if you change the permissions and then the key just get corrupted, and then you have to create a new key and it takes you like a lot of time to solve the issue. So if you follow these steps here, it's the same screenshot that I showed you before. You should open, you just open like a terminal, and then you have to have this, let's say steps, like you SSH, and then this is pretty much the path where your private key is saved. And then this information you copied from this place. And this is the port. So you need the node address and the port number. So basically what you do is you copy that information here, port, and the number. So I also put you here an example of the command line that I use. I saved my private key in this folder. This is the port address, and this is my port. I'm sorry, it's the node address and the port number. So after you have that, you should be ready to get into the node. So let me just open two terminals just to show you how it works. Basically, I just exit and exit this one too. So let's say this is gonna be one of the nodes. Remember that I told you that you need to remember your passphrase, because if you forget it, you have to create probably a new key pair, and that's gonna take you a lot of time. So what we did here, we SSH to the server. So we need to open another terminal and SSH to the client. So again, the same passphrase. Basically now we have two terminals. This is one computing node. This is another computing node. What we're gonna do is we are gonna connect to each other. There are a lot of things that you can use here for testing connectivity to know like the IP addresses, etc. For example, in this particular case, I can check the IP addresses. So for my server, the IP address is this one. And for my client, the IP address is gonna be this one. So the reason why I have these numbers here is because I kept the IP addresses, the ones that GENI gave me by default. But in your case, it's gonna be different because we gave the nodes specific IP addresses. So you should take a look. Like I just wanted to give you an example of like a similar thing, very similar thing that you're gonna do. Because otherwise it's gonna be like I'm gonna be doing all the lab and you might not learn anything. So that's why I wanted you to do the setting part so you can have like different IP addresses as well. And yeah, so that was the only reason. But I have different IP addresses. So the exercise tell you to install the first SSH to the node. We have access to the node now. Install iPerf. And what we do next is I also put you here like the details of how to get the IP addresses, just in case. And we move here. What we have to do in the server side is to open the server. So we use this command line. Then it's listening, and then we send some data. Yeah, so my internet is not really good. So that's why you see my bandwidth is not really great, but basically that's what you do. You're testing some connectivity, you know how much data are you transferring, how much data you're receiving, what is the bandwidth, and you're connecting to computing nodes in layer 2 setting. Again, I'm using here the IP addresses, the ones that you use when you were given IP addresses to the nodes. This is a screenshot that you need to provide for your to have to turn in for grading. So the same thing that I just showed you. You have the server and the client. You do some connectivity testing. You need to take a screenshot of that. And then pretty much we have we conclude the first lab, the first GENI lab assignment, and then you have to move on to the grading part. So the first point is mostly like that you have to provide us some screenshots. So some information about your account, the project that you joined, and also the result of the iPerf with the client and the server, specifically these two. And then the next questions are very interesting in the sense of that you need to try to elaborate your answers in the sense of you have you have to tell us a little bit about what are the capabilities or the benefits of having this experiment running in GENI or running like in a commercial internet infrastructure. So you can use the GENI wiki, but also you have to explain a little bit with your words, with your own words. And then we have some terminology here that you, of course, are going to find details in the wiki. We also talk about the federated identity and access management here. Why we have to ask for permission to get access to a project, for example. And then here, we wanted to keep this question as well, because as I mentioned before, we decided to just skip all the Omni tool command line exercise, and we move everything to JAX or the GUI, the graphic user interface. So still there is like a lot of information in the wiki. So you kind of need to do some explain a little bit about the role of the experiment control tools. So you have these two options, and then you can explain like what is the advantage of using Omni versus the graphic user interface tool. And then the significance of generating the SSH and SSL keys as well. So you can refer to the wiki again, but you have to write with your own words. After you finish everything, what you have to do is you have to release your resources. So basically, if you want to do that with the GUI, you click in the LAN little square here, setting, and then you press delete. That's to be it, and then you should be good for the lab. We also put like an observation here that you have to keep your virtual machine, your Linux virtual machine, if you're a Windows user, because you might have to use it again for the following labs. And that's it. I feel like you're gonna learn a lot with this lab. I tested it line by line. I tried to be very descriptive with things that you guys have to do. I'm gonna post this like right now, and I'm gonna put the video as well, the video link in Canvas. If you have any questions, you can reach me out by email, or I'm gonna be in office hours on Monday as well if you need me. Thank you.